Hi all, welcome to my channel. Today we are going to learn something about recommendation systems in this tutorial, and we are going to implement this recommendation system, our own recommendation engine, on a movie data set, and we are going to build a mini project on that with the help of Python and machine learning. Let's now have a look on today's topic that we are going to cover in this lecture. What recommendation system actually means. Some famous platforms that uses this system to grow their business. Then we will discuss about the types of recommendation systems in brief. Then we will see the basic mathematics to build a recommendation system. And then we will do the practical implementation on a movie dataset to recommend the movies. So what is recommendation system? What is it is actually? So here recommendation system is basically a filtering system that seeks to predict and show the items that a user would like to have. Recommendation engines basically are the data filtering tools that make use of some algorithms and data to recommend the most relevant items to a particular user. Now let's have a look on the platforms that use recommendation systems nowadays. There are the popular applications. There are Amazon and Flipkart. These are the shopping sites, we all know that. You might have seen that after placing some order, over the Amazon and Flipkart, they recommend you some kind of relevant products. Like if you search for mobile on the site, after a few days, they recommend you mobile covers or earphones like that. And there are basically two approaches to recommend. We will discuss that later on this lecture. There is Netflix also, popular for movies and series. Netflix also recommends you different movies based on your choices. In actual, they are not random. They recommend movies that you really may like, and you will see this in this tutorial. We will see how basically they read your choices and make prediction based on that. Moreover, you must have used Facebook and LinkedIn. Facebook suggests friends and LinkedIn suggests your networks. Both are running on the recommendation engines. So you might have noticed that there are some job portals also that recommend your jobs based on your skills that you set in your profile. We will try to see all of these concepts one by one. Now let's move to our next topic, that is types of recommendation systems. So basically, there are two types of recommendation systems. The first one is content-based recommendation. As you can see in this picture, user reads an article and then the similar kinds of articles are recommended to him. Let's understand this with a real-time example. Suppose you search machine learning tutorials on YouTube and watched some of them. Next time when you reopen YouTube, you see different ML tutorials from different channels are being recommended to you, or the other contents of the channel that you have watched earlier are being recommended to you. So this is the basically content based recommendation. Based on the contents you like, recommendations are made. And the next one is collaborative filtering approach. Let's suppose you are going to order a mobile set from Amazon. Sometimes you might have seen that they are recommending a combo of mobile phone and headset together. So that's the collaborative filtering. That means there are some people who already bought headset just after buying their mobile phones. So based on those records, Amazon is thinking, okay, if that person like to have that data set with them, then you may like too. That's why they are recommending the combo of these two. Hope you guys understand these two approaches. Today in this lecture, we are going to build content-based recommendation system only. Now suppose you are given two texts. One is text A and another one is text B. Text A contains a sentence that is mango, orange, mango, and text B contains orange, mango, orange. Now if I ask you to tell me if both of these are similar or not, even a child of first or second standard can say yes, they are same, because all the words in these two texts are same. Now this is the basic task that we are going to perform to recommend similar movies based on user's choice. Now let's try to understand the mathematics behind these recommendation systems. As you saw that text A contains two mangoes and one orange, and text B contains one mango and two oranges. And in that way, we can plot this text A and text B in a 2D plot. So the vector text A is 2 comma 1 and the vector text B is 1 comma 2. So if I plot this one, let me take the pen. If I plot these two vectors in a 2D plot, so let's take the points. So this is 1, this is 2, this is 3, 4, 1, 2, 3, 4. So text A is somewhere around 2 comma 1. This is my text A and my text B is here. If I draw these two vectors, this is my A and this is my B. Okay. So now how can you find the similarities between these two? You have to find basically the distances between these two vectors. Now there are basically two distances that you can think of. One is this Euclidean distance that can be found with the help of Pythagoras law, and there is another distance that we can think of, that is angular distance, that we denote with cos theta. Okay, so we will try to find out the cosine similarities between these two vectors, and based on that we will try to uh, you know recommend our movies on our real data set. So now let's do these all things with the help of Python on our VS Code editor. So let me remove this all and let's come to VS Code editor. Let me close this application. So there is my sentence. Sentence is basically a list of two strings, and the two strings that I mentioned in my PPT was, one was mango, orange, mango, and the another one was orange, mango, orange. So this is my sentence. Okay. Now if I ask you to count the number of mangoes and oranges in each string, how can you do that? So there is basically a class that is already built in scikit-learn library. So I am using that library here. So I have imported this count vectorizer class. I have imported from scikit-learn dot feature extraction dot text import count vectorizer. So now I will initiate the object of this count vectorizer class. I have initiated the object of this. Then I will call a method fit and transform. Then I will pass my sentence. I will store this in a variable called cn. Now if I print cm dot to array, let's see what output it gives. It gives me a 2D array containing 2, 1, 1, 2. So that basically means 2, 1 represents the first string. That basically tells us that there are 2 mangoes present and 1 orange. And for the second string, there are 1 mango present and 2 oranges. Now, how to find the cosine similarities? That is basically useful uh, for finding the similarities between all those texts, right? We have to find that also. So for that, we will initialize a variable called similarity score. SC equals to, we will call the function directly, that is cosine similarity. This is already a function in scikit-learn, so we don't need to create a instance of this. So we will directly call this function and we will pass my cm value here, and then if I print sc, now let's see what it gives. You can see it it also printed the uh, cosine similarity scores in a form of 2D matrix. And what is it what it's telling basically is, if you see the 2D matrix here, you can see it's saying 1, then 0.8, then 0.8, and then 1. That means here each string, here these two strings are present. One is orange mango, another one is orange mango orange. So the first string is comparing with the first string itself and the second string. So when the first string is comparing with the first string itself, that means there is 100% match. That's why it gives me 1. When the first string is going to compare with the second string, it says there is 80% matches. In this manner, when the second string is comparing with the first string, it says there is 80% matches. That's obvious. And when the second string is comparing with itself, it's saying that there is 100% matches. So based on this similarity scores, we will try to recommend the movies when we will work on our real-time dataset. And for that, we will go to a Jupyter notebook and work there. So I have already did all these things to reduce the time of this video. So before writing the code, you have to import all the required libraries. For that, I have imported pandas to work with our data frame. Now, the first thing that you need to do to work with a data set is to load your data set on your code. So for that, Panda has its uh, own method, that is read CSV, to read a CSV file. Then you pass the name of that data set. You will get this data set in my description below. You can download this data set from there. Next, I'm going to show my first 4 columns. So that's why I'm writing def.head 4. So it shows me only the 4 columns. And now let's have a look on our columns that's present in this data set. First one is index, that is common to all regular data set. All kind of data set uh, you know has this particular column index. Then is budget, that is the movie budget. Then there is a genres, this is the category of the movie. Next is the homepage link of that particular movie. Next is your ID, movie ID. Then there is keywords of the movie. Then there is the original language and the title of that movie. Overview, the movie description. Then there is also popularity score, the runtime of that movie, the spoken languages, the languages that are spoken in that movie or stored here. The status, is that movie released or not. The tagline, the vote average and vote count are also there. How many people have voted for that particular movie? That records have been stored also. And the next one is cast, crew, and directors. So these are all the features that this dataset has. Now, out of these all 24 features, I need only 4 features that I take into my consideration to make recommendation based on that. Now I have created a variable important columns, and there I'm creating a list. I'm storing 4 columns out of them. The first column is original title I'm taking. The reason behind this is, suppose you have seen Spider-Man. So my recommendation engine may think like that. Okay, you have watched Spider-Man, so you may like Spider-Man 2, Spider-Man 3, or all the Spider-Man series you may like. So based on that, I will recommend you. So this is my important feature. Next is my genres. That is basically the category of that movie that you have watched. Suppose you have watched a horror movie or a romantic movie. So my engine may think like, okay, so you like to watch this category's movies. So okay, I will recommend you based on that. So there is also a cast. I have taken this in my important features. That's because, suppose you only watch Avengers because of Tony Stark or Iron Man, right? So okay, my recommendation system will think, okay, so this guy only watches Iron Man movies, so he likes Iron Man. I know it. So let's recommend only the movies that Iron Man or that our Tony Stark has acted in. And after that there is a feature director. This is also important because sometimes what happens, you like the direction of a particular director, and based upon that our recommendation engine says, okay, this guy likes this director, so recommend all the movies that this director has made. So based on this our recommendation engine will work. So now I'm interested to see only the records of these four features. So that's why I'm saying df of important columns dot head 3. I'm taking only top three records here. Now we have to check if there is any null value present in any feature or not. So for that there is a method is null dot any. So if this method returns false, that means that particular column doesn't have any null values in it. And if it returns true, that means that particular column has null values in it. So after executing this, I'm getting that my original title doesn't have any null value. That's why I'm getting as false. But all the other three columns like genres, cast, and director, these three columns have null values. That's why it's getting true. So I can't work with the features having null values. So the thing I can do is either I can drop this feature, drop this record, or I can just replace these null values with some other strings or other things. So I will not drop this record there. I will try to replace the records with some other category. So for that, I just want to have a look on how many numbers of null values are present. So for genres, there are 28 null values. For cast, if you see, there are 43 null values present in cast feature, and for director, there are only 13 null values. So I see that with the respect of the size of our main data frame. Okay, so let me tell you. Let me see you this. So what I did. Okay, insert a cell above. If you see the shape of our data set, you will get to see that there are 4803 records, and out of them, only 30 to 40 null values are there in each column. So that's negligible, right? So we can drop this records, but we will try to replace them. So that's why I'm going to fill all these null values with fillna method, and I'm replacing the null values in cast with no cast. The null values in genres I'm going to replace with no genre, and the null values in director feature I'm going to replace with no director. So after that, I execute this, and if I now check that if there is any null values or not, you can see that I'm getting only false. That means all the null values have been replaced here. So now my data is completely clean. Okay. Now I'm going to get only the important features. Basically, I'm trying to combine all the important features. Basically, I'm doing the concatenation operation here. So for that, I'm defining a function get important features where I need to pass my data frame. Now I have created a blank list. Now for I in range 0 to data dot shape. So so if I say give me data dot shape or data dot set. So you can see that this is my number of rows and this is my number of columns. So I am I'm trying to iterate over the number of rows. So that's why I'm taking zeroth index of it, and I'm trying to append the data of original title I plus data of general I plus data cast I and director I. So what does it basically mean? If you look on this data set, wait a second, um, execute this. execute this one. If you look onto this data set, basically what it does is when you are trying to access an element from a data frame, you try to access with the help of the column and the rows, right? So the I starts from 0 up to 4803. Okay, so when the I is 0, that means I'm trying to access data of original title, comma 0. That means in original title in column, the record that is present in zeroth index will be accessed, and that will be concatenated with that I all the column values that I have in my zeroth index. And like this for all the rows here, all the columns values will be concatenated. So first it will concatenate the values present in zeroth row, then it will come to the first index, then will come to the second index, and in this way. Then I'm going to return my important features. Now I will create a column to hold this important feature in my data frame. So that's why I'm creating a new column, combined features, and then I'm calling this function and passing my df, that is my main data set. And when I'm executing this, and okay, so get important features is not defined. Why it's saying like that? Okay, execute this function first. After that, you will get to see the output. Okay. Now, if I say my main data set, we'll see there are 25 columns. Earlier, it has 24 columns. Now, one additional column you will get to see, that is our combined features. That is basically the concatenation format of all the important features here. After that, now I'm going to uh, calculate my cosine similarities. So for that, I have imported my required libraries, that is cosine similarity and count vectorizer. I have already seen this in my VS Code editor. How does it work? And next, I will convert this text to a matrix of token count. Uh, so I have already seen the uses of this count vectorizer class. So I'm going to feed this df of combined features. That is my new feature in this particular data set. So I'm fitting this to this class and store that in a variable called cm. Then execute this one. Then I'm going to find the cosine similarity score. Okay, so for that, I am here calling this function cosine similarity, and I am pressing my CM here. Now, if I want to see my cosine similarity, we will get to see that 2D matrix that we have seen in VS Code, right? So these all are my cosine similarity scores stored in this 2D matrix. So if I want to show its shape and see the shape of this matrix. Now, suppose this is the title that user gives. You can take this as a user input. Basically, we are going to recommend some movies based on our user's interest. So just assume that the user has watched Avatar movie recently. So this is my user input, and now I will define two helper functions. Basically, in this case, it will be helpful for that. Like the first function is useful to get title from index. So that's why I'm defining this function get title from index, and here I will pass my index, and what I will return is I will check that if that df dot index is equals to that index that the user gave, then return the original title of that particular index and return the zeroth position of that value. So I'm returning that, and in the same manner I'm returning the index from a title that user gave. So if df original title is equals to this title, then return the zeroth index of that particular index. So now getting the index of that movie that the user gave as input. So I'm storing that in a variable called movie index, and I'm calling that function get index from title. I'm passing the title that is Avtar here. Execute this. Execute this function. And if I say to print the movie index, we will get to see the zero. Uh, Now suppose let's see our so this is our zeroth index, right? Now suppose if I give this movie name as my user input, let's see what is written. Okay, put it in a single quote, execute this block, execute this function, execute this one, and you will get that index is 1. So it's working fine, right? So now I got my movie index. Now my next task is to find the similar movies. So here I'm going to enumerate the cosine similarity of that movie index and transform that into a list. So does what does it do? Basically, let's try to understand with the diagram. Suppose there are four movies: M1, M2, M3, and M4. Okay, and the similarities between M1 and M1 is obviously 1. M1 and M2 is 0.2. These are my all similarity scores, cosine similarity scores. Okay, so M1 and M3 is 0.5, M1 and M4 is 0.8. So when you enumerate this CS, this matrix, 2D matrix that stored basically the cosine similarities, you will get a list of tuples like uh, 0 comma 1. That means in zeroth index the element is 1. In the first index in the first index the element is 0.2. In the second index the element is 0.5. In third 0.8. So these all 0.1, 0.2, 0.5, 0.8, all these are my cosine similarity scores, right? Now I want to get most suggested movie. So that will be obviously based on our similarity score. So that's why we need to sort them based on our this core similarity score. Fine. So now let's see how to do that. Okay, so we get all my similar movies. You can see here that this is my index and this is my similarity score. This is my index. This is my similarity score. That as you know I have shown you. Now my next target is to sort the similar movies based on our core similarities that actually we are trying to do. So for this, there is a method sorted in Python. So I'm going to sort this similar movie. So I'm passing similar movies here. And what should be the key? The key should be the cosine similarities, right? So I'm applying here a lambda function where I'm saying that yeah x equals to x of 1. This is my zeroth index. This is my first index. So I'm saying my key should be x of 1. The element that is present in first index, that should be my key. And I'm saying reverse equals to true. Basically, that is going to sort this similar movies in descending order, and in that way we will get the movie that have the highest similarity score. So now if I print if I print this sorted similar movies, you will get to see all the movies with their index and similarity scores. So here you can see the first movie is approximately it's 100% match present in presented in first index. So that's the so basically this is the movie actually the user gave. So I don't need the movie itself that user gave. I need only the movies from the first index onward. So I'm going to say, hey, give me only the movies after my first index. Okay. So now if I, you can see the most suggested movie after Avatar, or after the movie that the user have watched, is present at 12th index with similarity score of 76%. After that, there is a movie with 63% score. So I'm getting the similar movies in a sorted manner. Now I want to print only the top 10 movies from the recommended list. Now there is already a function that I have made, that uh, how to get the title from index itself. So I'm saying, okay, so for movie in this sorted similar movies in this list, I'm iterating over. So I'm printing I plus 1. I have initiated I as 0, and I'm calling that function get title from index and passing movie of 0. Basically, movie of 0 means here I'm saying pass this one, and the 0th index is my actually the index value of that particular movie. So I'm passing the index value to this get title from index function, and I'm trying to get all the titles. And so to display only top 10 movies, I have initialized the counter here. So with each iteration, the I value incremented by 1, and when the I value becomes greater than 9, then I will say, okay, break the loop. So So here is my list that my recommendation engine recommended to the user who has already watched this movie, who has already watched this movie, right? Pirates of the Caribbean at World's End. Suppose you have watched this movie, okay? The next movie should be this, Dead Man's Chest. Then there is the Cars of the Backward. So like this, my recommendation system is working. So you can basically deploy this engine on any site with the help of Flask or Django or a simple Streamlit. So I hope guys you got the ideas of how recommendation engines work on the applications. This was the content based approach. So thanks for watching this video guys. Hope you like it, and share it with your friends, and don't forget to subscribe my channel to get more updates. Thank you.